In this video, I'll be doing some basic derivatives using the power rule. Before I start, we should know that the derivative, this is what the d over dx means, the derivative of any function, we'll say x to the n, is equal to the power, the exponent, n, so you bring that down, multiplied by the original function, and the original exponent is subtracted by 1. Now that we know the general formula for using the power rule, we can do a problem. So this question asks us to differentiate y equals x to the 4. So to do this, we say y prime to denote that we're finding the derivative. So this denotes that we're finding the first derivative. Y prime is equal to, so what we do is we bring down the power, so 4, and we multiply it by the original function, which is x to the 4, but we have to subtract the exponent by 1. So when we add all this together, we multiply it actually, 4x cubed, and that is the derivative for x to the 4. Okay, let's do another one. So let's find the derivative of 5x cubed. So we want to differentiate 5x cubed. Y equals 5x cubed. So we do the same thing. Y prime is equal to, and we bring down the power, we multiply it. So 3 times 5 is 15, and we subtract the power by 1. So we write the function, we write x cubed, but we subtract the exponent by 1, so it becomes 2. So this is the derivative, 15x squared. Okay, let's do another one. So this time, let's differentiate a constant. Let's differentiate y equals 7. So this one is pretty easy. We say y prime is equal to, so the derivative of a constant is 0. So this is the derivative of 7. And this could it could be any number. It could be 5, it could be 4. As long as it's a constant, its derivative is 0. Okay, let's do another example. So this time, let's differentiate y equals 3 over 4 x to the 8. So this is pretty similar to the ones we've done. So what we start, we do y prime equals, we take down the power, and we multiply it by the fraction. So 8 times 3 is 24. 24 over 4. We write the function x to the 8, or the number x to the 8. And we subtract the exponent by 1, so it becomes x to the 7. And we can simplify this. 24 divided by 4 is 6. So the derivative is 6x to the 7. Okay, let's do an example that's a little more challenging, because these are pretty easy so far. Let's do y equals, let's find the derivative of y equals x cubed minus 4x plus 6. So we want to differentiate this function. So we start by writing y prime equals, take the power down, 3, we subtract the power by 1, 3x squared. This one, the derivative of 4x is just 4, because there's an imaginary 1 here, and 1 minus 1 is 0, and anything to the power of 0 is 1, so we can just write that the derivative of 4x is 4. And we know the derivative of 6 is 0, so we don't have to write it. So the derivative of this function is just 3x squared minus 4. Okay, let's do another problem. So this time, let's differentiate a function with a square root in it. So y equals the square root of x. So this might look complicated, but it's not that bad. So the trick to this question is that square root of x is the same as x to the 1/2, just in a different way of writing it. So if we take the derivative of this function, we get y prime is equal to, we take the power down, 1/2, times, and we 1/2, we do 1/2 minus 1, so that'll be minus 1/2. So we could leave it like that, but it's easier if we rewrite it. Well, it's not easier, but it looks more pretty if we rewrite it. So 1/2, like the fraction, and x to the negative 1/2 is the same as writing the square root of x on the bottom. And this is the derivative of the square root of x. If you found this video helpful, don't forget to subscribe so you don't miss any of my videos.